Let's look at the derivative of an inverse function. In this particular problem, we have the function f of x equal 2x minus 1 divided by x plus 2, and we'll set that equal to y. Now what we want to do, just like we did in the last video, is to prove f is 1 to 1, and we want to compute the derivative of the inverse function at 5. So first of all, we can observe, and this is a very simple problem, we've done this many times in Calculus 1, the domain of f will be all real numbers except negative 2, and then of course with the limits at infinity, we see that the only real number that will not be in the range is 2, so the range will be all reals except 2. So to prove that f is 1 to 1, again, we show that f of a equal f of b actually implies a equals b. So in doing that, we have f of a is 2a minus 1 divided by a plus 2. F of b is 2b minus 1 divided by b plus 2. Now we cross multiply, so we get 2a minus 1 times b plus 2 is equal to a plus 2 times 2b minus 1. So each side you FOIL, and so when you FOIL this, you'll get a 2ab plus 4b minus b minus a 2. And then when you FOIL this or use the distributive law, you get a 2ab, a minus a 4b, and a negative 2. And I've underlined in blue the terms that automatically absorb. And so now what you can do is collect all the a's to one side and get a 5a, and collect all the b's to the other side and get a 5b. Of course, the 5's absorb and we have a equal b. So sometimes algebraically we can actually prove that as a function is 1 to 1. Sometimes we have to use continuity and the first derivative. It just depends on how inviting the function is to algebra. Okay, so now what we want to do, just like we did before, is find the corresponding point x in the domain of f or in the range of f inverse. So we do that by simply stating the following equation. That is 5 is equal to 2x minus 1 divided by x plus 2. And we just solve for x. And we know there's only 1 because it's a 1 to 1 function. And so when we cross multiply, we get a 5x plus 10 is equal to 2x minus 1. So we solve this like we're in Algebra 1. That would be what? A 3x is equal to a negative 11. So the corresponding x value is negative 11 thirds. So that would be a point on the graph of f. Okay, so now by the inverse function theorem, the derivative of the inverse at 5 will be the reciprocal, that is 1 over f prime evaluated at negative 11 over 3. And so of course we take the derivative of f by the quotient rule. So we get 2 times x plus 2 minus 2 times x minus 1 times 1 divided by the denominator squared. And of course evaluation at negative 11 thirds. Now notice the 2x is absorbed, but we get a 2x plus a 1 or 5 in the numerator, and then of course we reciprocate that, so let's go ahead and flip everything. So this will give an x plus 2 quantity squared divided by 5 evaluated at a negative 11 thirds. And so of course we just get a common denominator of 3, so we have 1/5 times negative 11 over 3 plus 6 over 3. That will give us, put the square here, that will give us 1/5 times negative 5 over 3 squared. So the square here will give us 5 squared divided by 9, and of course one of the 5's will absorb to give us 5/9. Again, the power here of the inverse function theorem is that we can actually compute values of the derivative of the inverse function without knowing its formula. Now of course this is a problem where you could easily compute the inverse function and do the problem that way, but what we're seeing here is a very important result that has deep ramifications in other levels of mathematics, namely Calculus 3 and Advanced Calculus and Analysis, where you study the inverse function theorem for vector valued functions. And we are done.